Hello, my name is Hannah Medved, and I'm an undergraduate research assistant at the Bowerman Sports Science Complex at the University of Oregon. I studied how prolonged mild hypohydration abolished differential blood pressure response to the exercise pressor reflex between sexes. The exercise pressor reflex is a sympathetically mediated reflex which increases blood pressure and total peripheral resistance during exercise. This is an attenuated increase in blood pressure in females compared to males during the exercise pressor reflex. These differences stem from the mechanically and metabolically sensitive afferent signals from the skeletal muscles, which increase the sympathetic nervous system. When there is an increase in the sympathetic nervous system, there will be an increase in blood pressure, heart rate, and total peripheral resistance. There are sex differences in the afferent, mechanic, and metabolic pathways. There is an influence on hypohydration on these responses, and as a lab, we are interested in learning about how hypohydration may modify the responses of the exercise pressor reflex. Hypohydration is a state of low body water. Due to recent data that shows that 33 to 74% of adults in the United States are chronically insufficiently hypohydrated. Due to a study, it was shown that there were no differences in blood pressure in males compared to females in a euhydrated state. From this study, it was shown that there was increases in blood pressure during the exercise pressor reflexes were attenuated in a very mildly hypohydrated state. The potential for sex differences in a hypohydrated state was not studied. Therefore, the purpose of this study was to test the hypothesis that increases in blood pressure during the exercise pressor reflex remain attenuated in females versus males during mild hypohydration. We took 22 subjects. They were each young and healthy. 11 were males and 11 were females. We did a randomized crossover design, meaning each subject came in for 2 trials, but it was randomized as to which they did first. One of the trials was hypohydrated, meaning that the subject could not drink or eat any high fluid substances for 24 hours, and the other trial was euhydrated, where the subject had their normal diet. Each subject came in for free measurements 24 hours before the study, where we measured their body mass. The subjects then came in 24 hours for their study day. Prior to the study, we took baseline measurements, which included body mass and blood pressure. We needed the baseline and pre-visit measurements to ensure that the subject obeyed the fluid deprivation protocols. The subjects then lay supine for 20 minutes. After that baseline, the subject squeezed a handgrip dynamometer for 2 minutes at 30% of their maximum voluntary isometric contraction. Blood pressure was taken at the end of the 2-minute stimulus. An arm cuff was then activated, which included all blood flow to the working muscle. This occlusion occurred for 2-minute stimulus as well. At the end of that 2 minutes, blood pressure was taken again. An automated oscillation and beat-to-beat finger photoplethysmography was used to measure systolic and diastolic blood pressure. The data were analyzed using a 2-way ANOVA with a home SIDEX test for adjustments. Before I get into the results section, I'm going to orient you all into how the figures are formatted. The y-axis is the dependent variable and the x-axis is the independent variable. The bars represent mean plus or minus the standard deviation. The white bar represents euhydrated, which is normal fluid intake, and the black bar represents hypohydrated, which is the 24 hours of fluid deprivation. The data points on each of the figures represent the individual subject responses. On the top of the graphs are the multiple comparisons data representing the main effect of sex, the main effect of hydration, and the interaction between sex and hydration. All the data are represented at change from baseline to the end of the 2-minute stimulus. In the first figure, we measured the change in body mass to approximate the change in the total body water. This was to ensure that the subjects followed all the fluid deprivation protocols. With this, we saw a decrease in the body mass of around 2 to 2.5%, meaning that the subjects did adhere to the protocols. During the hand grip stimulus, for systolic blood pressure, we saw an increase in both males and females during both conditions. However, there was no differences between males and females, and there was no differences between euhydrated and hypohydrated conditions. For diastolic blood pressure, in both males and females, we saw an increase. However, there was a greater increase in males compared to females, and there was no effect on hydration status. During the occlusion stimulus, we saw an increase in both males and females, with an attenuated increase in females compared to males. However, there was no effect of hydration status on the systolic blood pressure. And for diastolic blood pressure, we saw an increase in both males and females, with an attenuated increase in females. However, there was no effect of hydration status. These findings indicate that mildly hypohydrated females do not retain the attenuated increases in blood pressure during the exercise pressor reflex compared to males that is observed in euhydration. We still saw attenuated reductions in females when in a euhydrated state. However, these were abolished when in a hypohydrated state. Thank you.